Jupiter is believed to be the oldest planet in the Solar System. Current models of Solar System formation suggest that Jupiter formed at or beyond the snowline, a distance from the early Sun where the temperature is sufficiently cold for volatiles such as water to condense into solids. The planet began as a solid core, which then accumulated its gaseous atmosphere. As a consequence, the planet must have formed before the solar nebula was fully dispersed. During its formation, Jupiter's mass gradually increased until it had 20 times the mass of the Earth, approximately half of which was made up of silicates, ices and other heavy element constituents. When the proto-Jupiter grew larger than 50 Earth masses, it created a gap in the solar nebula. Thereafter, the growing planet reached its final masses in 3 to 4 million years. According to the Grand Tack hypothesis, Jupiter began to form at a distance of roughly 3.5 astronomical units, 520 million kilometers, 330 million miles, from the Sun. As the young planet accreted mass, interaction with the gas disk orbiting the Sun and orbital resonances with Saturn caused it to migrate inward. This upset the orbits of several super-Earths orbiting closer to the Sun, causing them to collide destructively. Saturn would later have begun to migrate inwards too, much faster than Jupiter, until the two planets became captured in a 3:2 mean motion resonance at approximately 1.5 astronomical units, 220 million kilometers, 140 million miles, from the Sun. This changed the direction of migration, causing them to migrate away from the Sun and out of the inner system to their current locations. All of this happened over a period of 3 to 6 million years, with the final migration of Jupiter occurring over several 100,000 years. Jupiter's migration from the inner solar system eventually allowed the inner planets, including Earth, to form from the rubble. There are several unresolved issues with the Grand Tack hypothesis. The resulting formation timescales of terrestrial planets appear to be inconsistent with the measured elemental composition. It is likely that Jupiter would have settled into an orbit much closer to the Sun if it had migrated through the solar nebula. Some competing models of solar system formation predict the formation of Jupiter with orbital properties that are close to those of the present-day planet. Other models predict Jupiter forming at distances much farther out, such as 18 astronomical units, 2.7 billion kilometers, 1.7 billion miles. Based on Jupiter's composition, researchers have made the case for an initial formation outside the molecular nitrogen N2 snowline, which is estimated at 20 to 30 astronomical units, 3.0 to 4.5 billion kilometers, 1.9 to 2.8 billion miles, from the Sun, and possibly even outside the Argon snowline, which may be as far as 40 astronomical units, 6.0 billion kilometers, 3.7 billion miles. Having formed at one of these extreme distances, Jupiter would then have migrated inwards to its current location. This inward migration would have occurred over a roughly 700,000-year period, during an epoch approximately 2 to 3 million years after the planet began to form. In this model, Saturn, Uranus and Neptune would have formed even further out than Jupiter, and Saturn would also have migrated inwards.